Welcome back to Key Safety Talks, everybody. We always try to give you the best safety tips and advice, but today we're going a little deeper into something that really affects all of that.
Yeah, we're going to be looking at physics.
Physics.
Yeah.
Bet you didn't see that coming.
It might seem a little out there, but trust me, it's going to be really useful for understanding safety in the workplace.
I never thought about it like that before.
Well, it all comes down to forces, energy, and how things move.
Like when you trip over a toolbox and go flying.
Well, that's one way to illustrate it. But yeah, we'll look at how those things actually work and what it means for staying safe.
Sounds good to me. So what are we using to guide us today?
We've got some notes from a physics textbook and a guide for safety professionals.
Cool. I'm ready to get started. Are you?
Absolutely.
Okay, so where do we even begin with physics? It seems like a massive subject.
It is, but for today, let's start with energy.
All right, energy.
Everywhere, you know.
Yeah, like I'm feeling pretty energetic today.
Well, that's good. But I'm talking about the kind of energy that makes things move and change.
Okay, I think I get it. So is that like electricity?
That's one kind, yeah. But there are a lot of other types. We're going to focus on two main ones for now, kinetic energy and potential energy.
Kinetic and potential. Okay, I'm taking notes.
Kinetic energy is basically the energy of motion. Anything that's moving has kinetic energy.
Like my car when I'm driving to work.
Exactly. And the faster something moves, the more kinetic energy it has. That's why speeding is so dangerous.
Because you're more likely to get a ticket.
Well, that too. But from a physics perspective, the faster you're going, the more energy is involved in a crash.
So if you hit something at a higher speed, it's going to be a much worse impact.
Exactly. The energy has to go somewhere. It might go into bending metal, breaking glass, or sadly injuring people.
Makes sense. So what about potential energy? What's that all about?
Potential energy is stored energy. It's like energy that's waiting to be released.
Okay, that sounds a little ominous.
Think of it like a ball at the top of a hill. It's not moving yet, but it has the potential to roll down and gain a lot of kinetic energy.
So it's all about position then?
In that case, yeah. That's called gravitational potential energy. The higher something is, the more potential energy it has. But there's also another kind of potential energy called elastic potential energy.
Elastic. Like a rubber band.
Exactly. When you stretch a rubber band, you're storing energy in it.
Sure.
And when you let go, that energy is released and the rubber band snaps back.
Okay, that makes sense.
Yeah.
So are there other types of potential energy?
Oh, yeah, there are lots. But those are the main ones we'll focus on for now.
Cool. So how does all this apply to safety? I'm trying to connect the dots here.
Well, think about it. If you're working at height and drop a tool, that tool has potential energy because of its height.
Right, and that potential energy turns into kinetic energy as it falls.
And if it hits someone on the head, well, you can imagine the consequences.
Ouch. Okay, that makes a lot of sense. So we need to be aware of potential energy and take steps to prevent things from falling.
Exactly, and that might involve using safety harnesses, securing tools properly, or even just being mindful of where you're standing.
Good advice. So we've talked about kinetic and potential energy. Are there any other important energy concepts we should know about?
Yeah, definitely. There are a couple of laws that govern how energy behaves.
Laws, like the laws of physics.
You got it. They're called the laws of thermodynamics.
Thermo something. It sounds complicated.
It's not as bad as it sounds. The first law basically says that energy can't be created or destroyed. It can only change from one form to another.
So it's like energy is constantly being recycled.
You could think of it that way. So in any situation, the total amount of energy stays the same. It just might change forms.
So like when a car brakes, the kinetic energy turns into heat energy in the brakes.
Exactly. And there's probably some sound energy too.
That screeching sound when you slam on the brakes.
Yep. That's energy being released.
Okay. I'm starting to see how this all fits together.
Yep.
So what of the second law of thermodynamics? What does that tell us?
The second law says that when energy changes forms, some of it is always lost as heat.
Lost as heat, so like it just disappears.
Not exactly. It still exists, but it becomes less useful. It's kind of like when you make toast. Some of the energy from the electricity goes into making the bread hot and crispy, but some of it is lost as heat to the surroundings.
So it's like energy gets a little less organized each time it changes forms.
That's a good way to think about it. And this has implications for safety, too, especially when we're talking about things like safety systems.
Safety systems, like airbags and seatbelts.
Exactly. Those systems are designed to absorb energy during a crash, but they can't be perfectly efficient.
So some of the energy is still going to be lost as heat.
Right. But the goal is to minimize that loss and make sure as much energy as possible goes into protecting the people involved.
That's really interesting. I never thought about safety systems in terms of energy before.
Well, it's all connected, and that's just the tip of the iceberg when it comes to physics and safety.
Wow. I'm already feeling like I've learned a lot. But I'm ready for more. What else is there to explore?
Well, we've talked about energy. Now let's move on to another fundamental concept. Force.
Force, like the Force in Star Wars.
Haha, not quite, though I guess you could say physics is the real force. But in this context, force is any push or pull that can cause an object to move or change its motion.
Okay, so like when I push a shopping cart or lift a heavy box.
Exactly. Those are both examples of forces.
So is gravity a force too?
It is. Gravity is the force that pulls us towards the Earth, and it plays a big role in a lot of safety issues.
I bet.
Yeah.
So what are some other types of forces we should know about?
Well, we can broadly categorize forces into two types: contact forces and action at a distance forces.
Contact and action at a distance. Okay, I'm following.
Contact forces are pretty straightforward. They happen when two objects physically touch each other, like when you push a door open or kick a soccer ball.
So it's pretty much what it sounds like,
Well,
contact.
yeah. And friction is another example of a contact force. It's the force that opposes motion between two surfaces that are in contact.
So like when you rub your hands together, you feel friction.
Exactly. And friction plays a huge role in safety. It's what allows your car tires to grip the road, and it's what keeps you from slipping and falling.
Okay, friction is definitely important. What about those action at a distance forces? Those sound a little more mysterious.
They do, but they're just as real as contact forces. Gravity is the most obvious example. It acts on objects even when they're not touching.
So the Earth is pulling on me right now, even though I'm not physically touching it.
That's right. Pretty cool, huh? And there are other action at a distance forces too, like magnetic forces and electrical forces.
Okay, I think I'm starting to get a handle on this force thing.
Yeah.
But how does it all tie back to safety?
Well, forces are what cause accidents. Think about it. If a car hits a wall, that's a force being applied to the car.
And the bigger the force, the worse the damage.
Exactly. So understanding forces can help us understand how accidents happen and how to prevent.
This is really fascinating. I'm starting to see the world in a whole new way, with forces and energy all around us.
That's the power of physics. It helps us understand how the world works at a fundamental level.
I'm eager to learn more. What other physics concepts should we talk about?
Well, we've covered energy and force. Now let's talk about mass and weight.
Mass and weight, aren't those the same thing?
They're often used interchangeably, but in physics they have distinct meanings.
Okay, I'm intrigued. Tell me more.
Mass is a measure of how much matter an object contains. It's a fundamental property of the object itself.
So it's like how much stuff is packed into something.
Exactly. And mass doesn't change no matter where you are in the universe.
Okay, I'm with you so far. So what about weight then?
Weight is a measure of the force of gravity on an object.
So weight is kind of like how strongly gravity is pulling on something?
You got it. And here's the key difference. Weight can change depending on where you are, because gravity isn't the same everywhere.
So if I went to the moon, my weight would be different, but my mass would stay the same.
Exactly. Your mass is a property of you, but your weight is a measure of your interaction with gravity.
That's mind-blowing. So why is this distinction between mass and weight important for safety?
Well, think about lifting a heavy object. You need to know its weight to judge how much force you need to apply.
Right, if it's too heavy, you could hurt yourself.
Exactly. And if you're designing a structure, you need to know the weight of the materials you're using to make sure it can support the load.
So understanding the difference between mass and weight can help us prevent injuries and make sure things are built safely.
Absolutely. It's all about applying these basic physics concepts to real-world situations.
This is amazing. I'm starting to see how physics is everywhere and how understanding can make us all safer.
That's what we're here for, to show you that safety isn't just about rules and regulations, it's about understanding the world around us.
I'm loving this deep dive. What else do we have in store?
Well, we've covered energy, force, mass, and weight. Now let's talk about motion.
Motion, like how things move.
You got it. We'll be looking at things like speed, velocity, acceleration, and how those relate to safety.
Sounds good to me. Let's keep this physics train rolling.
I'm with you. Let's dive in. Okay, so we're talking motion now, right?
Yeah, motion. Seems like a pretty basic concept.
It is. But there's actually a lot to unpack when it comes to how things move.
All right, I'm ready to unpack it. Where do we begin?
Let's start with speed. Everyone knows what speed is, right? It's how fast something is going.
Yeah, miles per hour, kilometers per hour, that kind of thing.
Exactly. But there's a related concept called velocity, and it's a little bit different.
Okay, how so?
Well, speed just tells you how fast something is moving, but velocity also tells you the direction.
So like if two cars are going the same speed, but one is going north and the other is going south, they have different velocity.
Precisely. Velocity takes both speed and direction into account. It's kind of like speed with a built-in compass.
Got it. So why is that distinction important for safety?
Well, imagine two cars approaching an intersection at the same speed.
Oh, that sounds like a recipe for disaster.
It could be. If they're both going the same direction, they might just pass each other. But if they're heading towards each other, well, that's a head-on collision.
And those are never good.
Nope. So understanding velocity helps us understand the potential for collisions and how to avoid them.
Makes sense. So is that all there is to motion? Speed and velocity.
Not quite. We also need to talk about acceleration.
Acceleration, like when you do the pedal to the
One example. Acceleration is any change in velocity. So it could be speeding up, slowing down, or even just changing direction.
Okay, so if a car is going around a curve, even if it's maintaining the same speed, it's still accelerating.
Exactly, because its velocity is changing. It's changing direction.
Wow, I never thought about it like that before. So why is acceleration important for safety?
Well, think about it. When a car crashes, it's basically experiencing a very sudden deceleration.
Right, it goes from moving fast to a complete stop.
And that rapid change in velocity can cause serious injuries, even if the impact speed isn't that high.
So the faster the deceleration, the greater the forces involved?
Exactly. And those forces are what can cause damage to the car and the people inside it.
This is all making a lot of sense. But I feel like we're missing something. Didn't our sources also mention displacement?
They did. Displacement is a measure of how far an object has moved from its starting point.
Okay, so it's not just about speed or velocity, it's about the actual distance traveled.
Right. And displacement takes direction into account too. So if you walk in a circle and end up back where you started, your displacement is actually 0.
Even though you walked a whole circle.
Yep. Because you ended up in the same place you started.
That's kind of trippy. So why is displacement important for safety?
Well, it can be useful for understanding the path of an object, like in an accident investigation.
So by looking at skid marks and debris patterns, investigators can figure out where the vehicles were and how they moved.
Exactly. Displacement helps them reconstruct the accident and figure out what happened.
Okay, I'm starting to see how all these motion concepts fit together. But it's a lot to keep track of.
It is. But thankfully, we have some laws that help us understand how motion works.
Laws. Like the laws of physics again?
You got it. Specifically, we're talking about Newton's laws of motion.
Oh, yes, Newton.
Well,
The guy with the apple.
That's the one. He was a brilliant physicist who figured out some fundamental principles about how objects move.
Okay, I'm ready to learn some Newtonian physics. What's the first law?
The first law is often called the law of inertia.
Inertia. I've heard that word before, but I'm not sure I really understand it.
It's basically the tendency of an object to resist changes in its motion.
So if an object is at rest, it wants to stay at rest.
Exactly. And if it's moving, it wants to keep moving at the same speed and in the same direction.
Unless something acts on it to change its motion.
Got it. That's inertia.
Okay, so how does inertia relate to safety?
Well, think about what happens in a car crash. The car suddenly stops, but your body wants to keep moving forward.
Because of inertia.
Exactly. That's why seatbelts are so important. They provide a force to stop your body from moving forward and hitting the dashboard or windshield.
Wow. Yeah, that makes a lot of sense. Seatbelts are basically fighting against inertia.
They are, and that's just one example of how understanding inertia can help us stay safe.
Okay, I'm impressed. What about Newton's second law?
The second law is probably the most famous one. It's often written as F equals ma.
F equals ma. I remember seeing that equation somewhere.
It stands for force equals mass times acceleration.
Okay, so it's telling us how force, mass, and acceleration are all related.
Precisely. The more force you apply to an object, the more it will accelerate.
And more massive an object is, the less it will accelerate under the same force.
Exactly. So a small car will accelerate faster than a big truck if you apply the same amount of force.
Makes sense. So how does this second law apply to safety?
Well, it helps us understand things like braking distances and impact forces.
Okay, explain that to me.
Sure. The heavier a vehicle is, the more force it takes to stop it, and the longer the braking distance.
That's why those big trucks need so much space to stop.
Exactly. And in a collision, the forces involved are directly related to the mass and acceleration of the vehicles.
So a head-on collision between two speeding trucks is going to be much worse than a fender bender between two small cars?
Unfortunately, yes. The forces involved are just much greater.
Okay. I'm definitely starting to see how understanding physics can make us better drivers.
That's the goal, to use this knowledge to make smarter decisions on the road.
Okay, so we've covered the first two laws. What about Newton's third law?
The third law is all about action and reaction.
Like karma?
Kind of,
Yeah.
but in a more scientific way. The third law says that for every action, there's an equal and opposite reaction.
Okay, I'm not sure I follow.
Think about it like this. If you push on a wall, the wall pushes back on you with the same amount of force.
So it's like a two-way street for forces.
Exactly. Forces always come in pairs.
Interesting. So how does this third law relate to safety?
Well, it can help us understand the forces involved in collisions.
So if a car hits a tree, the car exerts a force on the tree, and the tree exerts an equal force back on the car.
Precisely. And that's why it's so important to have safety features like crumple zones in cars.
Crumple zones, those are the parts of the car that are designed to deform in a crash, right?
Yep. They absorb some of the energy of the impact and help to reduce the forces on the occupants.
Wow, so those crumple zones are actually saving lives.
They are. By understanding Newton's third law, engineers can design cars that are better able to protect people in crashes.
That's incredible. I'm really starting to see the power of physics when it comes to safety.
It's all about using science to make the world a safer place.
Okay, so we've covered speed, velocity, acceleration, displacement, and Newton's laws. Is there anything else we need to know about motion?
Yeah, one more thing. Momentum.
Momentum, like when a team is on a winning streak.
Uh-huh. Not quite. Though I guess you could say a moving object has momentum. In physics, momentum is a measure of how much motion an object has.
Okay, so it's kind of a combination of mass and velocity.
Got it. The more massive an object is and the faster it's moving, the more momentum it has.
So a big truck going fast has a lot of momentum.
Tons. And that's why it's so important for truck drivers to be extra careful.
Because if they hit something,
Yeah.
all that momentum has to go somewhere.
Exactly. It might go into damaging the truck, the other vehicle, or even nearby objects.
Yikes. So how can we use our knowledge of momentum to stay safe?
Well, for starters, we need to be aware that heavier objects and faster moving objects have more momentum.
So we need to give them more space and be more cautious around them.
Exactly. Whether we're driving operating machinery or even just walking around, we need to be mindful of the momentum of objects around us.
This is all really eye-opening. I feel like I'm seeing the world in a whole new way with forces and energy and motion everywhere.
That's the beauty of physics. It helps us understand the hidden forces that shape our world.
And by understanding those forces, we can stay safe.
Exactly. Safety is all about understanding the laws of nature and working with them, not against them.
Wow, we covered a lot of ground in this physics deep dive. I feel like I need a physics nap now.
It's definitely a lot to absorb, but hey, you're doing great.
Thanks. But now I'm wondering, how do we actually use all this knowledge about energy, force, motion? I get the concepts, but how do they apply into real life?
That's the million-dollar question, right? It's one thing to learn the theory, but the real challenge is applying it in practice.
Exactly. It's like I've got all these physics tools now, but I need to learn how to use them.
Well, think of it like this. Physics is all around us all the time. Every move we make, every object we interact with, it's all governed by these laws.
So it's about seeing the world through a physics lens.
Exactly. Once you start thinking that way, you'll be surprised how much you notice.
Okay, I'm game. Give me an example.
All right, let's start with something simple.
Walking. Walking. Seriously. I mean, I do it every day without even thinking about it.
I know, right? But even something as basic as walking involves a lot of physics.
Like what?
Well, think about the forces involved. Every time you take a step, you're pushing off the ground with your foot.
And that creates a force that propels me forward.
Exactly. And there's friction between your shoes and the ground, which prevents you from slipping. So that's why it's so easy to slip on a wet floor.
Precisely. Less friction means less grip. And that increases the risk of a fall.
Makes sense. So what can I do to prevent that?
Well, first, make sure you're wearing shoes with good traction, especially in slippery environments.
Okay, good advice. Anything else?
Yeah, you can also adjust your walking style. Take shorter steps and walk more slowly.
So it's about being mindful of the conditions and adapting accordingly.
Exactly. It's about using your knowledge of physics to make smarter choices.
I like it. So we've tackled walking. What about something a little more complex?
All right, how about driving?
Driving. Now you're talking.
Driving is a great example of physics in action. Think about acceleration, braking, turning.
It's all about forces in motion, right?
Yep. And understanding those forces can help us be safer drivers.
Give me an example.
Sure. Let's talk about braking distance. The faster you're going, the longer it takes to stop.
Yeah, that's common sense, right?
It is. But it also has a physics explanation. Remember kinetic energy.
Oh, yeah. The energy of motion. Right. The faster you're going, the more kinetic energy your car has. And that energy has to be dissipated when you brake.
So it takes more time and distance to get rid of all that energy.
Exactly. And that's why it's so important to maintain a safe following distance, especially at higher speeds.
Okay, that makes a lot of sense.
hmm
What about turning? How does physics play into that?
Well, when you turn a car, you're essentially changing its direction. And that requires a force
A force. Where does that force come from?
from the friction between your tires and the road.
Ah, so if the road is slippery, there's less friction and it's harder to turn.
Exactly. That's why you have to be extra careful when driving in rain, snow, or ice.
Okay, I'm starting to see a pattern here. It's all about understanding the forces at play and adjusting my driving accordingly.
You got it. It's about using physics to be a more proactive and safe driver.
So we've talked about everyday activities like walking and driving.
Mm.
But what about the workplace? How does physics apply there?
Well, think about all the potential hazards in a typical workplace. Heavy objects, moving machinery, slippery surfaces.
It sounds like a physics obstacle course.
It kind of is. But the good news is that by understanding physics, we can identify those hazards and take steps to mitigate them.
Okay, I'm ready to learn. Give me some examples.
All right, let's start with lifting. We talked about weight earlier.
Yeah, the force of gravity on an object.
Right, so whenever you lift something, you're working against gravity.
And if the object is too heavy, I could injure myself.
Exactly. That's why it's so important to use proper lifting techniques.
Like bending at the knees and keeping my back straight.
Exactly. Those techniques help to distribute the weight more evenly and reduce the strain on your back.
So it's not just about brute strength. It's about using physics to my advantage.
Precisely. And it's not just about lifting, it's about any task that involves moving or handling objects, pushing, pulling, carrying.
Okay, so I need to be thinking about physics even when I'm just moving a box from one place to another.
Absolutely. You want to make sure you have a firm grip, that you're not overexerting yourself, and that you're using any available tools or equipment to help you.
So it's about working smarter, not harder.
Exactly. And that's where physics can really come in handy.
This is amazing. I'm starting to see how understanding physics can prevent injuries in the workplace.
It's all about applying these concepts to real-world situations.
And it's not just about preventing injuries, right? It's also about preventing accidents.
Absolutely. Think about things like slips, trips, and falls.
Those are some of the most common workplace accidents, right?
They are, and they often happen because of a lack of friction.
Like a wet floor or a loose rug.
Exactly. So, by understanding the importance of friction, we can take steps to prevent those accidents.
Like using non-slip mats and cleaning up spills promptly.
Exactly. It's all about making the workplace as safe as possible.
So we've talked about lifting moving objects and preventing slips, trips, and falls. Is there anything else we should cover?
Well, one more thing I think is really important is understanding the energy involved in machinery.
Machinery, like forklifts and cranes.
Those are definitely examples. But it could also be smaller machines like power tools.
Okay, so what do we need to know about the energy in those machines?
Well, for starters, we need to respect the fact that they have a lot of energy.
Right, they can do a lot of damage if they're not used properly.
Exactly. So it's crucial to be trained on how to use them safely and to always follow the manufacturer's instructions.
So it's about knowing the limits of the machine and not pushing it beyond its capabilities.
Right. And it's also about being aware of the potential hazards, like pinch points, rotating parts, and electrical components.
Sounds like there's a lot to be mindful of.
There is. But by understanding the physics involved, we can make informed choices and stay safe.
This has been an incredible journey. I feel like I've learned so much about physics and how it relates to safety.
I'm glad to hear that. And remember, this is just the beginning. There's always more to learn.
Well, I'm definitely inspired to keep exploring. Thanks for being such a great guide.
It's been my pleasure. And remember, safety is everyone's responsibility. So let's all use our knowledge of physics to make the world a safer place.
Great advice. Thanks for joining us on Key Safety Talk. Stay safe out there, everyone.